Hello and good morning, Sam here. I'll be solving another daily Leetcode question today. I think I'm on my fifth one. And I'll be trying to talk out loud about the different approaches I have as if I'm in a mock interview, kind of the things that an interviewer would be looking for. So feel free to follow along. This will be live and uncut, so feel free to skip around. The link will be below, and I have a timer up here in the top right, so let's start it and see what we've got. Number 2073, time needed to buy tickets. There are n people in a line queuing to buy tickets, where the 0th person is at the front of the line and the n-1th person is at the back of the line. You're given a zero-indexed integer array of tickets of length n, where the number of tickets that the ith person would like to buy is tickets of I. Each person takes exactly 1 second to buy a ticket. A person can only buy one ticket at a time and has to go back to the end of the line, which happens instantaneously, in order to buy more tickets. If a person does not have any tickets left to buy, the person will leave the line. Okay, so are we trying to get the total time? No. Return the time taken for the person at position K, 0 index, to finish buying tickets. To finish buying tickets. Okay. So we have 3 people, each wanting to buy 2, 3, and 2 tickets, and we're caring about the person in K equals 2, the last person in line. So the output's going to be 6, so we're returning the time taken, and each ticket purchase is 1 second. So in the first pass, everyone buys a lot tickets, so we have 1 ticket each, so 3. Now in decrements the amount of tickets. The second pass, everyone buys a ticket again, and so there's 0, 1, 0. And then the person at position 2 has bought their 2 tickets successfully at this point, even though the second person isn't done buying tickets yet. And it took 3 plus 3 seconds because it was 2 passes through the list. Okay. And here's another one where for the first person in line, in the first pass, everyone buys, so 4 seconds. The second 4 passes, only the first person needs to buy tickets. All right, interesting. And that ends up being 4 plus 4, I think, 8 seconds. All right, cool. It looks like the ticket's length is equal to n is never greater than 100, so no more than 100 people, and the number of tickets they could buy is less than 100 as well, at least one. Good to know. And k could be anywhere inside of this array. So how could we go about solving this? Kind of what I'm thinking about first approach is a brute force one. We buy tickets and keep incrementing time. We could use some sort of a pointer to current buyer, or push people in the list. If we did that, I think it would end up being it would be the number of tickets, O of number of tickets, total number of tickets, basically, which could end up being really large. O of, let's say n here is the length of a ticket, number of people, times the number of tickets. Let's just call that, I don't know, I guess it's technically 100 up to 102. Let's not do n, let's do number t for tickets. I think that's quite a lot, especially if you had 100 people, 100 tickets, you're going through 100,000. It would totally work. It would be fast enough for these ranges, but I think we could probably do better. And now I'm trying to think about what that means, some sort of mathy approach. We know, for example, with the first one, the amount of time it took to get the second one done was up to 2 for every single person before. So you take the max of, or the min of the value at k and each value multiplied. So let me just write that out actually here. Kind of what I'm thinking about here is, for this one, you know the answer is going to be 2, 2, 2, 2 tickets each 3 times. And we don't actually have to count our way through. We just know that we bought at least 2 tickets and at least 2 tickets and at least 2. If we had tickets in, let's say this had been 3 instead 2, here it would be the max of those values. And so this case is 2 plus 2 plus 2. Now if we had switched it around and k is equal to 2, we would have 2 plus 2 plus 3 equals 7, I guess, in this case. Is that right? Yeah. 3 plus 3. No. Yeah. 3 plus 3 is 6. Plus 1 is 7. Though that's kind of technically 3 plus 3 plus 1. Also, I'm noticing something kind of interesting here. What if k is not the first one? Like, what if k was in the middle here and we are doing it along these lines? Now we're getting one pass through this array, so 3 of them, plus a second pass, plus 1. It does equal 7 again. However, let's do this one and have a look, because I don't think it'll work there. One pass through the array gets us 4 times 1 plus 1 times 4 essentially equals 8, because we're at the beginning. I'm just trying to work my way through thinking about kind of the different options, because we have like k at the beginning and k at the end. What happens if this was like 7, let's just say? So if k is equal to 0, or sorry, k is equal to 1, we buy a ticket for everyone once, plus we buy for 2 people 3 tickets, and that's it. And then we reach the end, because we're only carrying by k equals 1, so it'll be 0, 0, 2, 0 at the end of that. So that'll equal to 4 plus 6 equals 10. How do we do that mathematically? I think we have to split up basically the array before and after. And what happens if we had 7 on this side? And let's just say 3 on this side. At the end of this, we would be looping through this. We'd have 2 left here. 0, 2, 0. Is that right? We've gone through once. I should write this out. Just so we had our 755, 757, 3. Then everyone loses 1 as we go through the array once. Then we do it again. 5, 3, 5, 1, 4. We do it again. 4, 2, 4, 0. And now we're only doing plus 3 because we're at 0 at this point. 3, 1, 3, and 2, 0. And actually, we don't care about the value at the end because we stop fast. So it'll actually be 2, 0, 3. And that'll just be plus 2, I think. Not the end point. We can't just subtract like the value at k from everything min 0 or max 0. It's only for those values to the left of it. And then plus 1 on the right side. Okay, so kind of the idea here is values left including of k, subtract k. Values right of k, subtract k minus 1. Yeah. And max to clip to 0. Clip to 0 on both. So maybe we could just regenerate the array. We go through the total number of people, n. Kind of thinking here, O of n solution no matter what. We have to count people. And O1 space, I guess, would be in the best case if we can do it in place. We might even be able to do it without in place. But for now, we might need to, kind of what I'm thinking is it might be as simple as iterating through the list, taking the values like for I in range n, here n is length of string, actually just for I val in enumerate. Can everyone see this? Let's pull this over to the left. And what I'd like to do, tickets and k. For I and val and enumerate tickets, if I is less than or equal to k, we'll have our total is equal to 0. Total is equal to the max of 0 and value minus val k. And we don't technically have to have it separate, but I'm just keeping it there. Well, let's actually not do that yet. Tickets of k, I mean. So if the value is greater than tickets of k before or equal, subtract k. Else total plus the max of 0 val tickets of k minus 1, because it's actually this would be a bigger number. Not what we want. We want it to be a smaller number. We're looking for the difference between the value and value minus, so what would it be in this case? Let's actually go through this. K is equal to 1, so for these two values here, 12 plus max of 0 and 7 minus 5 equals 2. Total plus max of 0 and 7 minus 7. So, sorry, 5 minus 5, which is not what we want actually. Okay, so that's not the exact logic we're looking for. We're trying to get the number up to k. I think it's maybe the min of k and the value. And then for that one, 7. Five and 5, that's correct. Let's change that. And then after, it'll be the min of tickets k and value minus 1, I think. No. Min of tickets k minus 1, 4. And whatever value is after, which in this case is 7, so that'll be 4. And then for the next one, 4 and 3. 3. And that gives us our total is equal to 5 plus 5 plus 4 plus 3, which equals 10, 14, 17. Is that correct? What do we think? 3, 4 is 12 plus 5, 17. I think that's right. Okay. let's check it on, let's quickly look at the one of the question ones and see if we'd have gotten the right answer with that one. You can see, like, I could try submitting it right now, but I'm trying to be able to do this as if you're in a real interview where you don't have access to running the code. So if we were in the situation of tickets is 511, k is equal to 0. If I is less than or equal to k, in this case 0, it'll be all 5. That's correct. We'd have total equals 5 plus, and then all the values after the min of k minus 1, 4, or those values, so it's 3. So 3 times 1 equals 8. And that is, I think, the right answer. Oops. Yeah, 8. All right. What happens if we have an empty array? Minimum size will be 1. If we had just 1, it would just be k is equal to that. It would be the total of whatever number of tickets in that val. So that'd be correct. Okay. I think we can try running this now. We're at what, 15, 16 minutes in? Just to see how it does. Oop, runtime error. I actually have to return total. Apologies. Return total. And let's get rid of all these extra things. We can always bring them back later if we need to. Like everyone to see the general code. And in fact, this becomes O of 1 space. We're just counting up. I'm trying to think of any other quick things. Well, actually, let's run it and then we can talk about maybe any other approaches. Oh, this needs to be 1 more. 2 more. There. All right, does it pass the test cases? Ooh, no, it does not. Why is it 0? Output was 5. Expected 8. All right, so we did something wrong here. Oh, max and min. I just hadn't changed the code here. If you guys were seeing that, sorry about that. I did it in the comments, but I didn't actually do it in the real code. Okay. Okay, it passes the 2 test cases. That's good to see. Let's have a look at the solution and see if it passes that. Yeah, good to see. Very nice. So we're kind of in the middle. There's plus or minus 10 milliseconds. I would say this is comfortably in the bounds of the backend speed. Sorry, the backend having issues, or not having issues, the backend having variability in just how it ran. So I wouldn't worry too much about trying to hyper optimize at this point. Getting to a solution that's O of 1, I think, is the key point. You can't do better than that because you have to go through all the tickets. There's no real way around it. You can use maybe standard libraries or NumPy arrays or something that would do it a lot faster because in the backend they have like either CPython or C. But in terms of algorithmic efficiency, I think I'm pretty happy with what we've got here. This just for fun, I want to see val k is equal to tickets of k, so we don't have to like get it every single time. I don't think that should matter because the interpreter should be smart enough to realize that, but let's see. Yeah, see, it's about the same, so no point in trying to prematurely optimize, though it does make it a little bit cleaner. Any other special things here? Technically, you could get away with not doing an if-else statement inside of the loop. You could iterate, create the for loops outside. So let's do that. So I up to k inclusive 1. And then after. So this way you don't have to do the k exclusive. K inclusive, K exclusive. Yeah, okay. However, yeah, it'll be empty. This should still pass. I don't think this will break. Now you no longer have to do if-else checks every single time. It passes the test cases. Let's see if it passes a submission. And there, it's quite a bit faster. So that's good to see. Here's a nice little optimization where if you can get rid of an if-else check inside of the for loop, you can let the Python interpreter kind of optimize this for loop because it's all fixed at this point. All right, very happy with this. I hope this was really interesting to everyone here. Let me know how you did, and if you, oh, one more thing, let's think about it. Any other approaches we could have done? Sorry to cut myself off. I think we're not going to ever do this because the mathy approach wins for sure. But I think you could do something along the lines of sorting the array, keep indices, and then use that to be able to, you know, the mathy still works here. Never mind, I can't see anything there. Can't see anything with hash maps. I'm trying to think about situations where maybe the number of people coming in is a stream that never runs out. That tends to come up in interview questions, or doesn't fit in memory. That would be interesting. It's fun to think about, and I think it's important to be able to kind of extend your solutions to these sorts of things. Since this is such a straightforward, nice little math solution, I think this would apply to almost any of those cases regardless. Yeah, very fun. I enjoyed that one a lot. I hope you all enjoyed it as well, and I can't wait to see you all next time. Cheers.